Miles, and then I'll get you your homework, okay? Just, it's fine.
Can we do them all now?
We're gonna do these together. So help me out. If I solve this inequality right here in blue, what do we need to do to both sides?
Add 8.
We need to add 8 to both sides so that x is less than or equal to 12. Right? Or, how about this purple inequality? What do we need to do here? We need to subtract 3 so that 2x is greater than 6. And then we need to?
Divide by 2.
So we have x is less than or equal to 12 or x is greater than 3. Right?
Yep.
Okay, now let's talk about or. We have to be in one or the other, correct? Okay, so our purple inequality. We have an open circle at 3, and which way do we go? Which way? We go to the right? My blue inequality. We have a closed circle at 12, and we go to the
Left.
Oh my goodness. It's weird, right? I need to be in one or the other. If I'm in one or the other, like I don't have to be in both. This is an or. So I can be in blue or I can be in purple. Well, blue or purple means what? What did I color? The whole number line. We have an or statement that covers the whole number line. It overlaps. So we would say that this is all real numbers. Every single number we could even begin to choose would satisfy x is less than or equal to 12 or x is greater than 3. It needs to be in blue or purple. That covers my whole number line. Any number is going to work. Now, if this was and, where would we be looking for? We would look for the overlap. And we have to overlap. Or is one color or the other. Okay? All right, let's look at example 2. You okay, Miles? Okay. All right. We're going to call this our red inequality. I like to change up the colors a little every now and then. Okay, in our red inequality, what do we got to do first? We're going to subtract 3 from both sides, so we have negative y is less than or equal to 5. Are we done?
No.
What do we need to do now? Divide by negative 1, we say with enthusiasm. Okay, y is greater than or equal to negative 5. Okay, and if we look at this purple inequality, what do we need to do to both sides? So y is greater than 7. Okay. Well. Okay. Well, let's look at what happens, because this is kind of weird. What do you notice about both of those inequalities? They're both greater I mean, one's equal to, right? But they both have greater signs. So when I graph this, I have -5 and above. I have 7 and above. Well, if this is an and statement, we have to look for where they're both true. We need to be greater than or equal to -5 and greater than 7. So where do we have the overlap of the two inequalities? Okay, so our answer is just y is greater than 7. Because that is where they overlap. That is where both inequalities are satisfied. Do you see why we're talking about these cases? A little bit weird? Yes.
So technically, if it was going to the left, would technically the one on the right have to overlap first?
I don't know about first. It's just when you put them both on there, where's the overlap? Okay. All right, let's do one more. Example 3 on the back. Okay. So here, this is one where we have 22 is less than -3c plus 4, and -3c plus 4 is less than 14. So let's go ahead and solve both of these inequalities. Okay, so I'll do orange for this first one. We will need to subtract 4 from both sides. So that we have 18 is less than -3c. Okay, now we have to be careful because what happens when we divide by -3? Okay, our sign switches. So we have -6 is greater than c. Do you agree? Okay. No, you don't? Okay, so you like it to look like this? Okay. I'll do that for you, Joey. All right. Now we have to solve our other one. So again, we're going to need to subtract 4. Oh, well, that's too bad. So when we divide by -3, we get c is greater than -10/3. Okay, so if c is less than -6, that would look like that. Do you agree? Okay. If c is greater than -10/3, -10/3 would be like -3 1/3. This is an and statement, right? Where do we have numbers that satisfy both? Well, that's a bummer.